Introduction to Vectors and Scalar Quantities. Hello and welcome to today's lesson. We are going to explore a fundamental concept in physics and mathematics that plays a crucial role in understanding the world around us: vectors and scalar quantities. By the end of this session, you'll have a clear idea of what these quantities are and why they are important in fields like physics, engineering, and mathematics. Let's start by discussing scalar quantities. These are quantities that can be entirely described by a number and an appropriate unit. For example, if I say star mass is 10 kilograms, I have fully described the quantity just by stating the number and the unit. Some common examples of scalar quantities include distance, time, mass, volume, and temperature. Here are a few more examples to help you understand. Mass is 10 kilogram, temperature is 27 degrees C, is 20 seconds, length is 2 meters, area is 5 square meters, volume is 4 cubic meters, speed is 5 meters per second. Notice that for all these quantities, we only need the magnitude, that is, the number and the unit. These numerical values without units are referred to as scalars. However, not all physical quantities can be described fully by just magnitude alone. This brings us to our next concept: vectors. Unlike scalar quantities, vectors require both a magnitude and a direction to be fully understood. Quantities that can be completely described by both magnitude and direction are called vector quantities. Let's take a look at a few examples. Displacement due north is 5 meters. Velocity is 15 meters per second due southeast. Weight is 30 newtons acting vertically downward. A force of 10 newtons is inclined upwards at 30 degrees to the horizontal. In all of these cases, the magnitude alone doesn't tell the full story. The direction is equally important, and that's what makes them vector quantities. Vectors were first studied in depth in the mid-19th century, and since then they have become a critical tool in the calculations used by engineers, mathematicians, and physicists. Vectors help express physical and geometrical problems clearly and concisely. For instance, in physics, quantities like force, velocity, and acceleration are best understood as vectors because they all depend on direction. In geometry, vectors are used to solve problems involving displacements and transformations. Vectors allow us to analyze motion in multiple directions, calculate forces that act in different directions, solve real-world problems in areas like engineering, physics, and even computer science. In summary, scalar quantities give us information about magnitude only, while vector quantities provide both magnitude and direction. This distinction is crucial for solving complex problems in the physical world. In upcoming lessons, we will dive deeper into how to work with vectors, including vector addition, subtraction, and their applications in real-world scenarios. So stay tuned as we continue to explore the power of vectors. Thank you for watching, and I look forward to guiding you through more exciting concepts in our next lesson. This version integrates the explanation of vector quantities and provides additional examples to clarify the concept of vectors and their distinction from scalar quantities. It also sets the stage for deeper learning in future lessons.